All right, so I'd just like to do a few examples of solving equations by factoring, just some extra practice. And so again, after each one of these, just pause the video, take a minute to think it out for yourself, and then we'll work it out here. So example one. (3x squared minus 2x equals 0). All right, so with this one, okay, it is quadratic, but notice that, remember, when we're trying to factor something, we should always look for a greatest common factor first, a GCF. So let's apply that general strategy here before we try any other fancy stuff with the quadratic. Okay, so notice that there's an x that we can get out of both terms. So maybe we factor that out first. Okay, so then we'll take the x out, and then that leaves 3x minus 2, still equal to 0. Okay. So that actually looks ready to use the zero product rule. We have factors, and the power of x is 1 in each factor. That's important. Otherwise, it's a lot harder to solve. We still have to keep factoring. So I'd say that's factored completely. Now we can split it. So first factor is x. So we got x equals 0. And then second factor, 3x minus 2. Equals 0. Okay, well that one's done. X equals 0 is one of the solutions. Over here, I think this is really similar to the last one we did. So we add the 2 over, 3x equals 2, and then we divide by 3. X equals 2 thirds. Done. Nice. All right, so that does point to a good method though. See if you can factor out a GCF first. It could be a lot easier than it looks initially. All right. Example 2. How about 2x cubed 6x squared equals negative 4x. All right, so take a second. Now, remember that our first step when we are trying to solve these is we need to get one of the sides equal to 0. And get everything else on the other side. So the first thing we have to do here, we're going to need to move that 4x over. So let's rewrite this. 2x cubed plus 6x squared plus 4x equals 0. Okay, so we got one side equal to 0. Step 2, we're ready to factor. Notice, can we get a GCF out of all those terms? So we got a 2, yep, and I can divide every term by 2. And then, oh, I also have an x in every term. So I can take a 2x out. So I have 2x, and then what's left, so that'll become x squared. Okay, if I divide 6x squared by 2x, that's going to be 3x. And then 4x divided by 2x will just be 2. All right. Now this one, so we got the GCF out, but now you can see that's a quadratic. Still got an x squared. That probably means we need to keep going, finish factoring. So now using our methods for these trinomials, we know, okay, leading coefficient's 1, So I'm going to have an x and an x as my first two terms, as my two first terms, I should say. Okay, and then we need to figure out what goes here. So what multiplies to positive 2 and adds up to positive 3? So we have positive, positive. That means we need the two positive factors of 2 because they add up to a positive number. All right, so 1 and 2, I think, will do it. 1 plus 2 equals 3. Okay, and now we're ready to use the zero product rule. We're completely factored, so let's split them up. This becomes 2x equals 0. We get x plus 1 equals 0, and then we get x plus 2 equals 0. Okay, so now over here, well, divide by 2 gives us x equals 0. All right, subtract that 1. X equals negative 1. And then subtracting the 2, we get x equals negative 2. So that's interesting because we haven't seen that happen before. This equation had 3 solutions. Why did that happen? So there is a connection between what your highest power of x is and the number of solutions you can have. So that can be a little bit of a clue. This one had a power 3 as the highest power. And then if all the factors that you get are different, you should end up with maybe 3 different factors, or at most 3 different factors. Then you're going to have 3 different solutions. Where, here, highest power is 2. 2 is going to be the maximum number of solutions we have. It is possible to have fewer, and we'll see an example of that next. So let's take a look at example 3. How about x squared plus 6x plus 9 equals 0? Okay, so going on what I just said, just trying to tie that back in, the most solutions, the largest number of solutions we could have are 2. But let's see if that actually works. We can't have more than 2 for sure. We could have less than 2 though. So how would that factor out? So you might notice, okay, x squared is a perfect square, 9 is a perfect square, so that's 3 squared. If I took 2 times x times 3, I get 6x. So this looks like a perfect square. So indeed it is. So we factor that out as x plus 3 squared. And now what that means is, okay, we do have 2 factors here. They're just the same. And then when we split them up with the zero product rule, well, we get x plus 3 equals 0 or x plus 3 equals 0. They're the same equation. So solving them both, we get a duplicate solution. So there is actually only a single solution to this equation. It's just, well, it's almost as if it can happen twice. I would just circle the 1 because that's redundant. And I think it's a good general rule. If you just get this scenario where it's this squared factor equals 0, you only need to deal with that equation one time. So each factor, each unique factor gets its own equation. All right. So let's look at example 4, and we'll see how we can extend this actually to any polynomial that we're able to factor. So here I have x cubed minus 2x squared minus 9x plus 18 equals 0. So that's a bigger polynomial than what we've done before, but we do know how to factor that. So let's use our usual methods. Okay, there's no GCF, but we have 4 terms, so that would tell me grouping. Okay, so how do we want to group them? I'd say just 2 and 2 again. And make sure that a negative sign goes with the 9 there. So, okay, our first group, the common factor will just be x squared. X squared out, that leaves us with x minus 2. All right. Next factor, or the next 2 terms here. Well, so we want to take the negative out because we need a positive x in the front. So take the negative, and I think we could also take the 9, right? Take the negative 9, and then that's going to leave us with x minus 2, and then all of that equal to 0. Okay. Now, we need to factor out the x minus 2. So pull the x minus 2 out. The leftovers are x squared minus 9. All right, so are we done according to the solving the equation by factoring method? Well, so just looking at the side we're trying to factor, is that completely factored? I don't think so. So we want to get x down to the first power if we can. And since that's a difference of squares, we could go ahead and finish factoring that out. So let's do that. Keep your x minus 2. And then we know that this is going to factor into x plus 3 times x minus 3. So we have x minus 2 times x plus 3 times x minus 3 equals 0. And again, so we'll get 3 equations out of that, which we might have suspected since the highest power is a cube. So our 3 equations are x minus 2 equals 0, or x plus 3 equals 0, or x minus 3 equals 0. All right, and then we just move everything to the other side. So we're going to get x equals 2, x equals negative 3, x equals positive 3. Voila.